All right. So, hi everybody. My name is Brendan Coyne. I work for Clear Creek Systems, based in the San Francisco Bay Area, Livermore. I've been with Clear Creek Systems for coming on about 5 years. Prior to Clear Creek, I was with a company called Baker Tanks. And prior to that, I worked as a salesman for an environmental remediation equipment company. Used to sell and rent out remediation systems. Thanks for joining us today on this webinar. I've worked with WGR on this Stormwater Awareness Week for maybe about 4 or 5 times over their 10 years. Congratulations on the 10 years to them. And again, thanks for joining me. It's tough to know the crowd that's going to be here, so I'm going to keep the presentations somewhat basic. Any one of these topics can be a webinar in themselves, but this is just meant to give an overall view of what anatomy of a stormwater treatment system looks like. Just not to talk about Clear Creek, but I just kind of want to know, some background on our company so you know where I'm coming from. They've been doing treatment since 1994. We serve from 6 locations in the West Coast. I'm based in Sacramento area. Our office is in Livermore, and we are approaching our 6-month anniversary with our new offices in LA and San Diego. We also have offices throughout the United States. This presentation will outline the anatomy of a project requiring stormwater treatment. The techniques, sorry, this little window here is in my way. I'm trying to move it. The techniques and the equipment that will be shown are used in our industry to safely, efficiently, and professionally collect and treat stormwater, all while meeting the regulatory needs. And I want to say, this is not an advertisement for Clear Creek per se. I've agreed to keep this as generic as possible. When I say the words "we," this is us collectively as professionals in the industry. So, we're all here at the end of the day to be the most professional we can, and that's what this is all about. All right. So let's trying to get to the next slide. There we go. Let's start off here with what folks might say is a bad day at the office. This is what improper planning looks like to stormwater professionals. We have a recent rainstorm that moved through this particular site. It's left puddles of what could be chocolate milk, but we know it's just the high turbidity stormwater on the ground. It obstructs our view of the ground. We have 2x4s that people could be tripping over if they're traipsing through the water. We don't know if there's potholes. People can step in, twist their ankles, and we would have some bigger problems. So not only does it not look professional, it is also a safety issue. This site, they took half measures, which are not always effective, right? Here we see the rocks laid down, and it looks like some trench plate off to the right, but they didn't continue through the whole site. We still have our stormwater sitting on the ground, looking like the chocolate milk. And as you can see, we're going to have equipment running through there all day long. It's just going to get messier and sloppier, especially if it continues to rain.
Hi, Brendan. Could you exit out of screen sharing and restart it. It looks like people are having trouble seeing the screen.
Okay.
I can see it, and if anyone else is having trouble, you might have to log out and then log back in. I'll paste that information in the chat.
All right. Let's see. Is that any better?
I can see it. Let me go. Can everyone see it? If you can see it, put it in the chat. Looks like we got a thumbs up, so.
Okay.
Perfect. You're good to go.
Great. So for those who couldn't see the prior slides, we did have some pictures of some sites that just had a lot, that we might call sloppy. They had stormwater through the construction site. This one's a photo of a residential property that's being developed, and there's some partial planning put in here, but we don't see the water going to any particular place for treatment or storage. So more work needs to be done there. Here we also see a urban development where they're probably putting in a parking garage here, and we see stormwater that is collecting in the top left quadrant there. In this particular site, this job site was shut down for several days. You might see from the photo that blue skies, sunny, and they're still shut down when we got there to this particular project. So that always costs money, and obviously we don't need to be wasting money these days. So what I want to get across right now with those bad day at work photos, a little bit of thinking ahead can reduce a lot of issues, right? Proper design and housekeeping are directly related to cost savings. So what does that look like? Well, it looks like a more professional setup. A plant setup allows for stormwater to settle out, a more professional appearance, and efficient and overall cost savings. In these photos, we see that water is not in the middle of your construction site. It's either in settling tanks or a pond of some sort. Now that pond on the right, again, I'm going to keep pointing you to that water. That's water that's going to need additional treatment. If you had somebody coming traipsing through that water all day long, it's never going to settle out. You're not going to meet the discharge needs of your permitting authority. So how do we get to that point? Well, we got to do a little planning. We need to put in some stormwater detention basins, for example, a place for that stormwater to go. In this case, they can be really rudimentary, as you see in the big photo on the left. Nothing too special in there. They have a little liner in the bottom of their pond, or they get more elaborate with some of the larger sites where you can see the lined pond. And also, you see the conveyance system there with the yellow pipe that's running through. At the bottom right, we can see actual submersible pump that's floating on top of or below a raft. As that water level goes up and down in the pond, the water can be pumped out from the top of that pond with the submersible pump. So if you think that water settles out over the time, over time, the clearest water is going to be on the top, and that's the stuff we're going to use. We're going to pump out and send off for discharge or further treatment. In this case, they would have to have discharge, some further treatment, because that water is really dirty looking. So sometimes you can't have water running all the way to your nice detention basin or settling pond. You gotta put in a sump at your site. And again, we're going to place the pond and the sumps at a low point of the site, right? Makes sense. We want to take advantage of that natural water flow, the gravity. It's going to pull it to one area or another, and you can design that into your site. We want to make sure it's in a low traffic area. We don't want equipment have to move any equipment because other people need to work there. So we want to think that through. Also, we don't want to be doing this during El Nino. Nobody wants to be traipsing around in a foot of mud in a pit like this that's half filled with water. It's best done during dry weather. I know that makes sense, but often these systems are put in only as a last resort.
Looks like we have a comment from Mel saying settling ponds can also lead to vector issues.
That is true. Safety, again, always a top priority. I put this in. It's maybe a little overkill with the life ring preserver there on the left, but you know, we want to think these through. You know, vector issues can be a problem with settled water, and we don't need to settle water for more than a day or two if we can treat for it. But you know, these are good areas for you know, slips. If somebody slips into your pond, will they be able to get out? I've seen some pretty crazy ponds. All right, and in this case, the safety officer required a life preserver to be put there. So it's always got to be a priority these days. So in this slide, we're going to see what a proper layout looks like. A little bit of forethought has been put into this site now. In this case, we have all of our drainage going to the bottom left side of this photograph, where it is picked up in a sump and piped all the way around. You'll see the white PVC, the white line going over the top left sector there. That's a PVC pipe pumping all the way around their site. So all their equipment and people, they have the whole site. They can work and not be worried about running over pipe from the stormwater treatment system. Another photo of the same site, we see that white PVC pipe being pumped, or being pumped over to a settling tank that's behind the construction trailer there. And in this case, they didn't need a lot more treatment than that. Their stormwater would settle out very nicely and didn't need any further filtration or pH adjustment. And again, you can see the access. Nobody's being inconvenienced. Now, I mentioned that, you know, I'm hitting some basics here. Maybe boots on the ground type guys, mostly, but there's a lot of other work that goes into these stormwater systems. I'm sure if you're on this call, you know everything that goes into these systems and treatment for the stormwater. But I'd be remiss if I didn't at least mention them. The SWIP. We want to know how long this part of the project's going to last, where we're going to potentially have these types of issues. we'll have civil drawings available in the planning stages where a lot of times they'll put some thought into this type of stuff before the project even turns the shovel of dirt. We want to make sure that our permits are known and where we're going to put the water. Where's it going? Is it going into the sewer? So is it going into the storm drain? Is it going right into the river that has the protected salamander? We need to know all this information as we get going. Also, especially in a lot of the bigger cities, we have redevelopment that goes on properties that have had a lot of mixed uses through the decades, or through time. So we may have other issues than pH and turbidity that we need to be aware of and know about. Is there issues with metals there? VOCs? Was it a dry cleaner at one site at one time? These are questions that we ask ourselves. I want to take a quick note and talk about water chemistry. Now, I pointed out a raft with a submersible pump on it in a previous slide, and I said we like to use those because we like to take the clear water off the top. As we know, if we were to go get a glass and fill it with dirt from our backyard and swirl it up, the water will tend to want to settle out, and as time goes from left to right, that's what it might look like if we do that. My slide is not going to the next one. I'm going to stop the share and reopen this, guys. Sorry.
If you click on the screen of your PowerPoint, and it should be able to advance, and then try using your arrow keys.
Yes, you're right. How about that? Thank you, Rebecca. So moving on from this slide, we can look at this table here and kind of give us an idea of what we can expect our stormwater to do once it mixes with the soils. The gravel, if it was just you're just dealing with gravel and you mix it in a cup like that with water, it's going to settle out, in one to 10 seconds maybe, right? And we get into some finer particles, you could see how long it takes to settle out. It all depends on the fineness of the particles. When we start getting into the silts and clays, we're starting to think of additional treatment that might be needed for stormwater. I always like to point out the 207 years for certain colloidal particles there. So what if you get to a site and you really don't know what you're looking at yet? One quick thing that you could do is pull out your empty Gatorade bottle from your truck, go out, fill it up with some soil, mix it in some water, shake it up, let it sit on your tailgate for a few hours and come back and take a look at it. If it still looks like that bottle, you're going to have some issues with stormwater quality. Again, it's not scientific. It's just a boots on the ground. What are we dealing with type of project right here? In addition to how clear the water is, we also have to consider what the pH is doing on the site as well. So in order to discharge, we want to be in the neutral range. Often that could be 6 to 8 pH that we are looking for. It's not often that pH needs to be treated for, but a percentage of the time we do have to treat for pH. And I wanted to mention that here. So getting a little bit more into the nuts and bolts of what the anatomy of a stormwater treatment system looks like, I wanted to kind of show the treatment process, okay, and how that works together to help you treat and discharge your water. We're going to start at the left side at the job site. We have our job site pond where the water's collecting, and I'll go through each of these components and talk about them a little bit, how they work and what we want to consider when we spec out these this type of equipment. All right. Ooh, wrong way. All right, first, we want to pump out of our job site. Often we'll use a submersible pump or trash pump. When we select these pumps, often the little contractor pumps that you get at Home Depot aren't the ones you want. So I wanted to let pass on what to look for. So we want solids handling pumps. That can be, in this case, submerged or float on a raft. These submersible pumps on the left-hand side are all electrically powered. Or you might see some other centrifugal pumps that are not submersible. They might collectively be known as trash pumps. Solids handling. Often they'll be able to handle small rocks and that sort of thing that gets kicked up in the water. These can be electrically or mechanically powered. So the picture I have here is an electric powered trash pump. When we select these pumps, we need to consider a few things. We need to consider the gallons per minute and how far they're needing to pump. So if we're pumping up a big hillside, we need a more powerful pump. If we're pumping 137 acres of stormwater, we're going to need a high capacity pump. The pumps are selected based on the site conditions. Well, we talked about where it goes. How we got to get it there, so we convey that to, in this case, for my example, we're going to pump it over to some settling tanks. It could just as easily go to another pond, a place where we allow the residence time to aid in settling out the sediments and dirt that gets sucked in there. These tanks, you've probably seen them. They're either red, blue, green. There's other colors, but you see them on the sites. There's 17,000 to 21,000 gallons in capacity. Some of them have weirs inside, which separate compartments and allow for additional settling. The number of these tanks is their size to allow stormwater to settle at the bottom. Good rule of thumb on these tanks is for every, let's say, 100 to 200 gallons per minute, we'll need one of these tanks to properly settle out sediments. All right. The tanks also allow for surge capacity. What's surge capacity? Well, sometimes it rains really hard and sometimes it doesn't. So we need our system, like when we treat for stormwater, we like to treat at a constant flow rate if possible. So these tanks allow for some surge capacity and allow for a steady treatment. So once we're in those tanks, we're going to need another pump to pump out the submersible or trash pump at the job site pit, we're not going to have that pump pressure anymore. It's going to be lost once it gets in the tanks. So we'll need a transfer pump coming off those tanks. Again, electrically or mechanically powered. Often they are not submersible pumps. These are trash pumps. Again, solids handling. We won't have as many solids, but there could be in there. These pumps are capable of variable flow rates. Often they're capable of variable flow rates to handle different needs on a site as the stormwater amounts increase or decrease. And these are obviously sized for the treatment train that follows. Again, gallons per minute, and the back pressure on the rest of the equipment that you might have to filter out your stormwater. So by the time we get to the sand filter, or there's other types of filters as well, bag filters, cartridge filters, there are even more than that. By the time we get to this sand filter skid, we're now getting into the meat and potatoes of our stormwater treatment if we need to do so. What decides whether or not we need to do further treatment is what the water quality looks like. If it's looking like that chocolate milk, we're going to need to do some treatment. If the pH is out of the neutral range, we're going to need to do some additional treatment. I'll talk about that type of treatment later, but right now I'm going to leave that out, and we're going to talk about the sand filter skid. All right, sand filters are great. They're often used in your backyard, in your swimming pool. Oftentimes we'll have a sand filter or similar. It's a mechanical filter. All right, normal operation removes particles greater than 35 microns, plus or minus. That's pretty small. With addition of flocculant, we can reduce turbidity to less than 10 NTU. What does 10 NTU look like? It looks like the jar on the right side of that photo. It's pretty clear. One thing that I like about the sand filters, and why I wanted to talk about them with you today, is they have the ability to automatically backwash. So when they become plugged up with sediments, you don't have to have somebody on the site necessarily to go change out bags or cartridges or other types of filtration. Once the sand filter starts to plug up, it automatically cleans itself. It's a nice feature on these this type of equipment. From the sand filter, sometimes you can go right to discharge, but in this instance, let's pretend that we have some other needs on the site. Could be metals, could be oils, VOCs. So these media vessels can be put at the very end to treat for a variety of contaminants. They hold various media. The media obviously is selected based on what we need to treat for. Used to remove metals, VOCs, or contamination. On the most complex of sites, we'll see multiple trains of this media, and that usually means a lot of money, unfortunately. But they are available, and the media is selected based on, again, what you have going on. The number of vessels is determined by the flow rate. I should say the number and or size of the vessels is determined by the flow rate and the contaminant. I want to talk about active treatment. In California, that's attachment F of the general permit. Active treatment is used to treat for turbidity and pH. The module that I show here controls and injects flocculant that is used to reduce turbidity. Turbidity is a measure of how clear the water is. NTU is the unit. And if we do need to treat for turbidity and pH, we'll need to comply with the permit regulations and attachment F as it relates to active treatment systems. So I wanted to talk about, if you remember my slide on the sand filter, I said that sand filter will treat to 35 microns by itself. If you were to put, say, coffee or chocolate milk or something through that sand filter, it would take all the particles out, you know, floating solids and everything, but in the end, you're going to have chocolate milk come out of the bottom, right? It's still highly turbid. So we can use flocculant to bind the particles in that water to make larger particles that fall out of solution. Once these smaller particles are bound up together, they become bigger particles that can be caught by the sand filter or other filter. So often, once we figure on the right flocculant, we can reduce turbidity to less than the 10 NTU. This is just an example. So on the looking at the bottom left, well, let's start at the top one, beginning and end. We have really yellowish water. I don't know if you could see in the slide, little beads starting to form in there. That's the flocculant starting to bind the particles together. Left to sit there, in the top photo, right jar, you see the particles fall out of solution, and we're left with a cloudy water, right? That cloudy water can be sent through the sand filter and end up looking like the clear water jar on the bottom right of this photo, right? That process is going to happen pretty quickly. This illustrates that. It's quite amazing if you've never seen a demonstration, but this is what I have to show you today. So we go from no treatment to adding the flocculant to 30, 60 seconds pretty quickly, and then at 30 minutes we can get pretty clear. Finally, when we meet our needs for pH and turbidity, we can discharge legally to state waters. If anybody has any questions on the basic anatomy of a stormwater treatment system, this would be a good time. So I want to show this short little video. It's about, it's not only 15 seconds or so. What it looks like, and for what proper treatment looks like and how effective it is. And especially on sites where you have high visibility, you have endangered wildlife, you have high regulatory oversight, you have sites where the owner has a lot to lose if something goes wrong. it's really nice to be able to show them how effective their treatment system is. In this case, then the water that you'll see in the foreground is coming off a stormwater treatment system. The water in the top, at the top right, the cloudy water, that's water coming from further upstream, doesn't have any relation to this construction site. So I'll hit the play button now. Oh, that didn't work. I thought I would hit the play button. The clear water is the treated water. I guarantee you, if your regulator came by and saw this, they'd turn around and walk away. There's the outfall from the stormwater treatment. The diffuser at the top there, so you don't have a big pressurized pipe jetting into the hillside. So, in summary here, a well thought out plan results in an economical setup, a smooth installation, which directly results in manpower savings, and your job site keeps running. We can use basic resources. We don't need to go crazy trying to catch up with an existing problem. And finally, a professional appearance. I don't know if any regulators are on here, but you know, the high visibility sites are the ones that get highlighted. I just want to emphasize a professional appearance is going to go a long way in reducing any problems. Of course, the system has to work as well, but they just to give you an indication of the types of sizes these can get. This is a project that, well, you know, if you figure 100, 200 gallons a tank, you can kind of put together how big a project this particular one is. This is what it should look like, guys. Gals, sorry. All right. That kind of wraps up what I had for an anatomy of a stormwater treatment system. I've got a few minutes left for any questions. I did want to take a couple of minutes just to talk about Clear Creek Systems if you're interested in learning more about us. Are there any questions that I could answer?
If you have a question, feel free to unmute yourself and ask, or you can put it in the chat. While we're waiting for those questions, Brendan, why don't you go ahead and talk about Clear Creek?
Great. Just to give a general overall what we do. This would be I think 3 or 4 slides of this stuff here. If you do drop off, thank you very much for speaking with me. I'm happy to meet with anybody at any time to look at your site, make suggestions, free of charge. We have temporary and permanent systems available. We've treated very low flow rates to in excess of 4,000 GPM on these systems. Wide array of contaminant. Everything you saw there is pretty standard for us. We use, you know, the best available technologies, comprehensive treatment as needed. We try to be cost effective. None of this comes, this equipment comes free of a cost. I understand the pressures people are under, and so does my company. We have a very safe company. I think our EMR is in the 0.6 range. something like that. Sometimes that's very important to companies. We're a project-based company, not a product-based. So I'm not trying to push you any. Clear Creek is not going to try to push anything on you that we have to sell. We like to take a look at what you have and make the recommendation from that. That can include very basic bag and filter cartridge system to treat your stormwater. Cost you $400 a month plus a pump, or they can get quite elaborate, as you see. So we take a combination of the industry technologies and make a complete system. We do sales, design, installation. We work with consultants a lot in our line of work, or construction companies, consultants. We have qualified operators of active treatment systems as required by Attachment F, and we can also help with the permitting. We have a lot of different other industries as well. Construction, stormwater, we've talked about that a bit. Dewatering operations, well development, treatment, well development, we treat well development water, industrial stormwater, process water. Did want to leave you with a little bit of a cheat sheet on this. 1 inch, how much water will you have to deal with? You can do a quick little calculation. 1 inch of rain equals a little over 27,000 gallons of water on 1 acre. Right, you can do the math from there. And again, these tanks, 18,000 to 21,000 gallon capacity. So for 2 inches of rain, you're going to probably need at least three tanks, right? All right, that's kind of what wraps it up for me today. Any other questions or any needs? We do the brown bags. If you want lunch and learns, I can do this webinar. I can make it to your company. Whatever we can do to help, we're here for you. And thanks for listening to my presentation.
Thank you, Brendan. This is great. And if you missed any part of the presentation, you want to watch it again, it will be up on our website in about 24 hours. And we have 3 more workshops today. We have one about Caltrans Water Pollution Control Manager training requirements. That one starts at 1 o'clock. So if you want to join that, head over to our website. And there's a couple more today. And then we got a bunch of workshops on Thursday and Friday. But thank you so much for joining. And we hope you have an awesome rest of your day.
Thanks again.